Welcome back, everybody, to another lesson. Today we are going to be discussing multiplication. So, what is multiplication exactly? Well, it's the idea that it is repeated addition. So, let's give you, for example, 2 plus 2 plus 2 plus 2 plus 2. Well, we have 5 2's there. We are adding 2 5 times. Instead of sitting here and adding all these up all day, it is going to be the same as we have the number 2 and you have it there 5 times. So that would be the same as 2 times 5, which in fact would give us 10. So here's another example. Say I have 3 times 3 times 3. Whoops, 3 times, I'm sorry. That's a different lesson. We'll be getting to that soon enough, but I meant 3 plus 3 plus 3. We're adding 3 times. That is going to be the same as 3 times 3, which happens to be 9. So multiplication is a shorthanded way of writing repeated addition. So I'm going to do my lovely magnets again. Let's say I have, let's see here, what am I going to do? I think that's good enough for now. I have 3 groups of magnets here, right? I have 2 in each group, so I have 2 magnets in each group, and I have 3 groups of them. How many would I have total if you count them? I'd have 6. Alright. That's one example. Let's use all the magnets I have here. So, looks to be I have 4 groups of magnets now, right? In each group I have 3 magnets. And I have 4 groups of them. If you count them, how many do I have? 3, 6, 9, 12. I got 12 magnets. So that is also the same thing again. If you want to, I wouldn't recommend it. You do 3 plus 3 plus 3 plus 3. That's 3 4 times. So add them up, you would also get 12. But I think 3 times 4 is a lot nicer. So that sideways X symbolism means multiplication. Let's take all these magnets here, put them aside, okay? Come on with me. Come on. Alright. So some ways you'll see multiplication problems written. Oh, let's say I have 9 times 2. That's one way to write a multiplication problem. You also might see it 9.2. That's another way to write multiplication. And especially as we move into pre-algebra and algebra, we're going to get away from using X. For this lesson today, we're going to heavily use that X symbol, but as you go into the future towards algebra, you'll want to get away from using X for multiplication. You'll want to use the dot, or you may see something like 9 parenthesis 2. That is also the same thing. Those all mean multiplication. Alright. So, a couple of properties here to make your life a lot easier for multiplication. Let's say this is going to be called the zero property of multiplication. Alright. right? What does that mean? That means if I take any number, any arbitrary number A, and I multiply that times 0, I'm going to get 0. So we'll do a couple of examples here, all right? We have, let's say I'll do 3 times 0. Well, that'll give me 0 according to this property. Any number times 0 is 0. I'll do 199 times 0. Again, any number times 0 is, in fact, 0. So that's going to make your life a lot easier for multiplication. Alright, there's another property that's also very easy that I'd like to share with you. This is called the multiplicative identity. Multiplicative identity. Did I say identity? No, that's not what I want to say. Though I'm not an English teacher, I still believe in proper spelling and grammar. I do believe in that. So, multiplicative identity. If I take any arbitrary number and I multiply that times 1, I will get that same number back. So, we'll do 3 times 1. Any number times 1 gives you that same number back. 3 times 1 is 3. If I take that 199 and I multiply that by 1, any number times 1 will give you that same number back. That will give you 199. Alright. I think we're good on that so far. Now, this is going to seem like a long lesson because I want to teach the times tables. These are very important, especially as we get into doing higher numbers with multiplication, and especially as we also get into division, which will be the next lesson. So, I don't think we need to do 0 or 1's tables because anything times 0 is 0, anything times 1 is itself. So, we'll start with 2. 2 times 1 is going to be 2. So, because anything times 1 is itself. So then we have 2 times 2, which is the same as 2 plus 2. In this case, that's going to give you 4, because you're adding 2 twice. Now we have 2 times 3. You just add 2 more to what you have here. 2 times 3 equals 6. 2 times 4, well, that equals 8. 2 times 5, that's going to give you 10. You see the pattern here? If you count by 2, it goes up by 2 each one you do. So, I'll also do 2 times 6, that's going to give you 12. 2 times 7, that'll give you 14. 2 times 8, that'll give you 16. 2 times 9, that'll give you 18. I'll get to multiplying by 10 in a minute here, but so you notice every number you multiply by goes up by another 2. So 2 times 1 is 2, 2 times 2, 4, 2 times 3, 6, all the way to 2 times 9, which is 18. Okay. Let's save a little writing here. So we did that for counting by 2's. Let's do the 3 times table now. If you can count, basically you got this. So 3 times 1 is 3, because any number times itself is that number back. 3 times 2 is 6. If you count by 3, you'll get the next number. 3 times 3 is 9. 3 times 4 is 12. Keep counting by 3 to get the next number. You'll have it for your times table. 3 times 5 is 15. 3 times 6 is 18. 3 times 7 is 21. 3 times 8 is 24. Then we got 3 times 9, which is 27. So those are all your 3 tables there. So if you just can add 3 to each new factors of 3, you get what your result is. All right. Let's do, you guessed it, the 4s. So, if you pick up on a pattern here, any number times 1 is itself. 4 times 1 is 4. To get 4 times 2, you'll just simply add 4 more. That'll be 8. 4 times 3, add 4 more to that. It's going to be 12. 4 times 4 is 16. 4 times 5 is 20. 4 times 6 is 24. 4 times 7 is 28. 4 times 8 is 32. 4 times 9 is 36. Those are that's your times table for 4. We're going to go up to 9. If you're wondering how far are we going, we're going to go up to 9. Alright, so next we're going to do for 20. We're going to do for 5. So again, any number times itself here is going to be that same number. 5 times 1 is 5. 5 times 2 is 10. 5 times 3 is 15. 5 times 4 is 20. 5 times 5 is 25. 5 times 6 is 30. 5 times 7 is 35. 5 times 8 is 40. 5 times 9 is going to be 45. So if you notice, from the first one, you just keep counting by 5 for every multiple, and you'll get your result. Alright, we're over halfway there, folks. These timetables I am teaching are so important for what we're about to be doing next. They are utterly very important. So I apologize if this is a longer lesson than normal, but I must impress these upon you as we get further into higher multiplication and even division, which will be the next lesson's division. Okay, that leaves us with 6. 6 times 1 is 6. We add 6 more, we get 6 times 2 being 12. We get 6 times 3, that's 18. We added 6 more. And 6 times 4, we added 6 more to that. That's going to be 24. 6 times 5, add 6 more, you got 30. 6 times 6, add 6 more to that, you got 36. 6 times 7 is 42. If you add 6 more, add another 6 for 6 times 8, you get 48. Then add another 6 for 6 times 9, you get 54. Alright, almost there. We're on to 7, 8, then 9. We are going to get there. Alright, 7 times 1, that's 7. So if we get 7, to get 7 times 2, we'll add another 7, that would be 14. To get 7 times 3, add yet another 7, that's going to be 21. 7 times 4, add another 7, then you get 28. 7 times 5, well, that'd be 35. 7 times 6 is 42. 7 times 7 is 49. 7 times 8 is going to be 56. And 7 times 9 is 63. So that's your 7 times. That's all the stuff for 7 times. Next, we move on to 8s. Alright, 8 times 1, well, that's 8. If we add 8 more, that's going to be 16 for 8 times 2. We add another 8 for 8 times 3, well, that'll be 24. 8 times 4 is 32. 8 times 5 is 40, because we keep adding 8s to get the next result. 8 times 6 is 48. 8 times 7 is 56. 8 times 8 is 64. Then 8 times 9 is going to be 72. The last one for the times tables, then we'll move on to some other multiplication. Alright, multiplying by 9. So, again, anything times 1 is itself. 9 times 1 is 9. To get 9 times 2, you add another 9, you would have 18. To get 9 times 3, that adds another 9 to that, you'll get 27. 9 times 4, well, it would be 36. 9 times 5 is going to be 45. 9 times 6 would be 54. 9 times 7 would be 63. 9 times 8 is going to be 72. And then 9 times 9, well, that would be 81. Alright, so those are your times tables from 0 through 9. So, let's say I have the number 2. If I wanted you to write a multiplication expression for that, what would you write for me? That's the same as 2 times 1, because you have 2 one time. 2 times 1. Now, if I add plus 2, I now have 2 twice. That's the same as 2 times 2. That's the only time. This is the only time where plus and times are the same. It's not the same with any other numbers, but 2 plus 2 and 2 times 2. Let's say I tack on yet another 2. I'm asking you to do what? 2 times 3. That's what that's equal to, because I have 2 3 times. And I think you get the picture from there. If I kept going, I could do 4 and 5 and so on. But we're not going to do that. We've kind of already seen examples. So, let's say I have the number, I'm going to teach you how to multiply by 10. So I have 10 times 1. Well, multiplying by 10 is easy. In fact, if it's just zeros and a couple single numbers, it's easy. You have 1 times 1 is 1. And then 0. You just, how many zeros do you have here? You have 1 0, so you add a 0 to it. Alright. Of course, that also doubles because you have anything multiplied by 1 as itself. So what if I had 10 times 9? Well, again, 1 times 9 is what? 9. How many zeros do we have there? 1. So you would get 90. Let's take it up a notch. What if I had this equation? What if I gave you this, 10 times 10? What are we going to do there? Well, we have 1 times 1 is 1. How many zeros do you see? 1, 2. There are 2 zeros. You'll just add the 2 zeros down below, and that would give you 100. So, what if I do 10 times 15? Well, we start with the fact that 15 times 1 is itself. And how many zeros do we have? We have 1 0. So that would give you 150 for your answer. Alright. What if we had 100 times 100? Again, we're going to have 1 times 1 is 1. Then how many zeros do we have there? 1, 2, 3, 4. Well, we'll tack 4 zeros onto that, which would give you 10,000. 100 times 100 is 10,000. So, not too bad. So what if I had 1,500 times 20? Well, we know 15 times 2 is what? 30. 15 and 15, that's 30. So stick with your initial result of 15 times 2. Then you add 3 zeros because there's 1, 2, 3. So add 2, 3. That would give you 30,000. That would be your answer. So multiplying by 10, 100, 1,000, which we'll do one more. Let's say I have 1,000 times 9,000. Again, what is 1 times 9? That's going to be 9. How many zeros do I have? 1, 2, 3, 4, 5, 6. I need to add 6 zeros onto that. 4, 5, 6, which would actually give me 9 million. So 9 million would be my answer. I think we get the multiplying by zero properties. Those are just shortcuts for you to help you out. Okay. Now, I'm going to teach you the commutative property of multiplication. So there's that good old commutative property coming back again. So, like in addition, it also works on multiplication. So let's say I have, say for example, I had 2 times 3. That is going to be equal to 3 times 2. It'll give you the same result. So, we know 2 times 3 is 6, that's true. 3 times 2 is 6. Again, think of the commutative property like the numbers commute. Let's give you one more example. Let's do, doesn't matter, let's do 9 times 7. Well, if you have 9 times 7, that's the exact same thing as 7 times 9, according to the commutative property of multiplication. It doesn't matter how you arrange it, as long as it's multiplication or addition. Which also opens up our favorite associative property. It also works for multiplication. Multiplication and addition it works for. Alright, so let's say I have 2 times 3 times 4. So remember, in math, parentheses tell you what to do first. But the associative property states I could arrange a parentheses in any order as long as it's entirely multiplication. That would be equal to 2 times, if I move the parentheses, 3 times 4. So you would get the same result here if you move the parentheses. So let's do that math here, okay? What is 2 times 3 in parentheses first? That is going to be 6. Then you have that 4 outside of there that you haven't multiplied yet. Well, 6 times 4 is 24. How about 2? Then, so you have 2 outside the parentheses times 3 times 4 is 12. You'll have 2 times 12, which happens to be 24. So this proves, there are many other examples I could give, but this proves that the associative property also works for multiplication as it does addition. By now you should have seen with subtraction that the associative property does not work for it, nor does the commutative. And that's going to be the same case with division when we learn that next lesson. So associative and commutative only work on addition and multiplication. Alright, let's get into some longer multiplication problems. And we'll start with something easy like 12 times 2. Yes, it's true we haven't gone that far yet, but if we have 12 times 2, we start again with the rightmost digits like you would addition and subtraction. So 2 times 2 is 4. Then you're going to do 2 times 1. So here's where it varies. This is where it varies. You stick with the same digit you're in on the right hand side on the lower number and go to the next one. So you'll have 2 times 1, which is 24. So multiplication is a little bit different than addition and subtraction. 24 would be your right answer. How about, we'll do 19 times 3. Actually, no. Let's not do that yet. I want to stick with simple enough. No offense. I think we can get away with 13 times 3. 3 times 3 is what? 9. Then we got to do 3 times 1, which is 3. So you see, to start with, you're sticking with the same place. You're sticking with what's in the ones place to start and multiplying it by what's above it. Oh, let's do one more. Let's do 14 times 2. What is 4 times 2? Well, that's going to be 4 times 2 is 8. Then we need 2 times 1, which is going to be 2. That gives you 28 for your answer. Okay, I think we get the idea with that. How about we move on to, now I think we can do problems like 15 times 3. 15 times 3, so we got 5 times 3 is what? 15. Well, we have an issue here. We can only bring the 5 down. That 1 we have to put into the next place. So it's somewhat like addition, but it's different because 5 times 3 is 15. I keep the 5. I carry the 1 over to the next place. But you know what? Why don't we do this in blue ink? That would make more sense. Do this in another color. I want you to be able to see exactly what's going on here. 5 times 3 is 15. We keep the 5, carry the 1. So then we do 3 times 1, which is going to be 3. Then we add that 1 plus 1. So 3 times 1 is 3 plus 1 is 4. So that's how we got 45. Alright, so how about an equation like 19 times 9? Let's start here. 9 times 9 is what? 81. Well, we can only keep the 1. We're going to have to carry that 8 over to the next place. 9 times 1 is what? 9 times 1 is 9, plus 8 is 17. So your answer is going to be 171. That would be your answer for that. Okay. How about one more easier one, then we'll get into a harder one. 39 times 8. So we start at the right. What is 9 times 8? 72. So we have the 2 here. We're going to carry the 7 over to the next place. What is 8 times 3? 24. What's 24 plus 7? 31. So the answer would be 312. All right. So let's get into now a multiplication with 2 digits. How about 19 times 12? What if you're faced with a problem like this? I'm probably going to use 3 different colors for this. So 9 times 2 is what? You start at the right. 9 times 2 is 18. You keep the 8. You carry the 1 to the next place. 2 times 1 is 2 plus 1. You add what the digit that's up there. That's going to be 3. So far, it would look like we're done, but we're not. Now, whenever you have a second digit here, you have to begin another row. To start the second row, you bring down a 0. You automatically have a 0 to start the second row. Then you may do 1 times 9. What is 1 times 9? That is 9. So that 1 I carried before should go away. That only worked for that one time. What is 1 times 1? That's going to be 1. So now you got to take these 2 rows that you got to add them together. Which I think, why don't we use red? I haven't really used red. What is 8 plus 0? That's 8. What is 3 plus 9? That is 12. So you have the 2, you carry the 1. 1 plus 1 is 2. So you should get an answer of 228. That would be your final answer. No worries, we'll do some more problems. How about one like 39 times 54? It looks hideous, doesn't it? That does not look like a very good problem, but it is. So, we start with, again, we start at the far right in your ones place. What is 9 times 4? That will give you 36. Now let's write in blue ink for that. Red's for the other results. So 9 times 4 is 36. We can keep the 6. We got to carry the 3. So then we stick with that 4. What is 4 times 3? That is 12. Plus that 3 up here is 15. Alright, now we have a second digit here. It's in the tens place. So we got to start another row. To start the second row, we automatically have a 0 in the ones place. And let's do ourselves a favor before we go too much further. Let's get rid of that 3 that we carried over so we don't confuse ourselves. Now we start with 5 times 9. What is 5 times 9? That's going to be 45. So you have that 5 you keep. You bring that 4 over here to the next place. So what is 5 times 3? 15 plus 4, 19. Then you're going to add these 2 lines together to get your final result. So what is 6 plus 0? Well, that is 6. 5 plus 5 is 10. You have the 0, you got to carry the 1 over. What is 1 plus 1 is 2, plus 9 is 11. You keep the 1, carry another 1. 1 plus 1 is 2. Your answer should be 2,106. That would be your answer. Let's do another example with 2 digits. Oh, here's a good one. 99 times 99. No, that's not good. Only for the fact that it might lead people to wonder which place are we in. How about 99 times 53? Yeah, that'll work. 99 times 53, okay? So again, we start at the far right. What is 9 times 3? That's 27. So 9 times 3 being 27. We keep the 7 down here. We got to move that 2 over to the next place. Stick with the 3. 3 times 9 is also 27. Plus 2 is 29. Okay. So far we have 297, but we're not done yet. Next thing, since we have a second digit here, that 5 is another digit, we got to start a second row, which means we bring down a 0 automatically in the second row in the ones place. And go ahead and erase that 2 we carried from before. We don't want to mix anything up. Now we may start with that 5 times the right 9. What is 5 times 9? 45. So the 5 stays down here and the 4 comes over here. What is 5 times 9? Well, that's 45 plus 4 is 49. Then you're going to add these together. So you add your 2 rows together and you should end up with your new result. Oh, why don't we write in brown? That might be better. What's 7 plus 0? 7. Right? What is 9 plus 5? That's 14. So we have the 4, we carry the 1. 1 plus 2 is 3, plus 9 is 12. So we have the 2, we bring the 1 over. 1 plus 4 is 5. So your answer to this equation would be 5,247. Yikes. Okay. Yes, we're even going to do some 3 digits. I'm not going to go 4 digits. I'll take it easy on you. We'll only go up to 3 digits. So let's say I have 123 times 456. Well, what does that look like? That doesn't look like a very nice number, I can tell you that, but again, start with your rightmost numbers. What's 3 times 6? That should be 18. So 3 times 6 is 18. You keep the 8 down here, bring the 1 over to the tens place. Sticking with your 6 that you're multiplying across with. 6 times 2 is 12, plus 1 is 13. Keep your 3 down here, carry your 1 over here to the hundreds place. What is 6 times 1? That's 6 plus 1 is 7. Alright. We are starting a second row. We're starting with a second number now, so we got to automatically throw down a 0 in the ones place. And do yourself a favor and erase these 1s you carried before, just so you can avoid confusion. Now we do the 5. We'll start with the 5. What is 5 times 3? That is 15. Alright. So you have the 5 here. You're going to bring the 1 up here to the tens place. What is 5 times 2? 10 plus 1 is 11. So you keep the 1 here. Bring the 1 over here to the hundreds place. What is 5 times 1? 5 plus 1 is 6. Now, since we have a third number, we have to start a third row, and this time you're going to bring down 2 zeros right away. You'll have a 0 in the ones and tens place. And then, like before, erase the ones that you carried. Now you may start with the number 4 and multiply that by 3. So what is 4 times 3? 12. So keep your 2 here. Bring your 1 over to the tens place. 4 times 2 is 8. Plus 1 is 9. And what's 4 times 1? Well, that's going to be 4 last time I checked. So you'll add all these up. Now you add your 3 rows together. So what is 8 plus 0 plus 0? 8. Alright, 3 plus 5 is 8 plus 0 is 8. 7 plus 1 is 8 plus 2 is 10, so I'll keep the 0 here. I'll bring the 1 over to the next place. 1 plus 6 is 7 plus 9 is 16. Keep bringing your 6 here, carry the 1 over to the next place. 1 plus 4 is 5. So your answer to this equation is 56,088. That looks pretty hideous, but that's what the answer is. I got a couple more examples for you. Alright. Let's do 397 times 153. Now let's raise this up a bit so you can see more of what I'm writing. But nonetheless, we'll stick with this. 397 times 153. So we start at the very right here. What is 7 times 3? 21. So we keep the 1 here, we bring the 2 up above to the next place. And dang it, I'm supposed to use blue ink. We'll start over. I'm supposed to be using different colored inks so we can see it better. It's kind of hard when it all blends together. So 7 times 3 is 21. Keep the 1 there, bring the 2 up to the next place. 3 times 9 is, so 3 times 9, 27 plus 2 is 29. Keep that 9 here, bring the 2 up to the next place. What is 3 times 3? 9 plus 2 is 11. So that 11 would stay here. Alright, now we have to begin, we have a second digit, which means we have to begin another row, which means you throw 0 in the ones place automatically for the second row. Do yourself a favor, delete those 2's you carried over, erase them. That way you don't confuse anything. Now we may do 5 times 7. What is 5 times 7? 35. So the 5 will stay. The 3 we have to bring up to the next place. What is 5 times 9? 45 plus 3 is 48, so the 8 will stay down below. We'll carry the 4 to the next place. So then, what is 5 times 3? 15 plus 4 is 19. So the 19 will stay there. Alright. Now we have a third digit, so we have to begin a third row. This time you're going to throw 2 zeros in. You're going to throw in a 0 in the ones place and in the tens place to start with. If we were multiplying by 4 numbers, guess what? You begin a fourth row, you would throw in 3 zeros in the next row. So basically it's however many rows you're on minus 1 for how many zeros you throw in. But we're going to go ahead, we're going to erase those numbers we carried over. This should be easy. What's 1 times 7? 7. What's 1 times 9? That's 9. What's 1 times 3? That's 3. Now we shall go ahead and add these up, which I need my brown ink. So, what is 1 plus 0 plus 0? Well, that's 1. Easy enough. What is 9 plus 5? That's 14 plus 0 is 14. So keep the 4 here, bring the 1 over here. 1 plus 1 is 2 plus 8 is 10, plus 7 is 17, so we'll have the 7 here. We'll carry that 1 over to the next place. What is 1 plus 1? 2 plus 9 is 11, plus 9 is 20. We'll have a 0. We'll carry a 2 over here. 2 plus 1 is 3, plus 3 is 6. So your answer will be 60,741. Yeah. That's how you can get all kinds of numbers. Alright, one more example, then that'll end the lesson. I know this has been a long lesson. Thank you for bearing with me, but multiplication is a lot to teach, and it's a very important foundational skill for higher math. So, let's do 765 times 432. I want to write it higher. Sorry, guys. 7, not that high. Come on. 765 times 432. Okay. So again, we start at the far right. What is 5 times 2? That's 10, so you'll keep the 0 here. You'll bring the 1 up to the next place. And then we'll do 2 times 6, which is 12, plus 1 is 13. Keep the 3 here, take the 1 up to the next place. Sticking with a 2, you have 2 times 7 is 14, plus 1 is 15. Alright. We have a second digit here, which means we got to begin a second row, which means we throw a 0 into the ones place automatically. Excuse me. Throw a 0 into the ones place automatically and erase those ones that you carried over from before. Okay, now we may address what is 3 times 5. Sticking with the 3 in the middle in the tens place. What's 3 times 5? 15. So the 5 stays. The 1 gets carried to the next place. What's 3 times 6? 18 plus 1 is 19. The 9 stays. The 1 gets carried over to the next place. What is 3 times 7? That is 21 plus 1 is 22. So we'll write the 22 here. Alright, and we have a third digit here, which is the hundreds place. We actually need to throw in 2 more zeros to begin the third row. Alright. Now we may address what is 4 times 5. That is 20. You'll keep a 0 here. You'll carry the 2 to the next place. What is 4 times 6? 24 plus 2 is 26. 6 stays. The 2 gets carried to the next place. What is 4 times 7? 28 plus 2 is 30. So now you've answered all 3 rows. You can now suddenly you can add and find your final answer. So you notice it starts as a big multiplication problem, then it ends as a big addition problem. That's exactly how it works. So this one's easy. What's 0 plus 0 plus 0? 0. That's going to be simple enough. What is 3 plus 5? 3 plus 5 is 8, plus 0 is 8. What is 5 plus 9? That's 14 plus 0 is 14. Alright, so we have the 4. We got to carry the 1 up to the next column. What is 1 plus 1? 2 plus 2 is 4, plus 6 is 10. Keep the 0, carry the 1 to the next column. What is 1 plus 2? That's 3, plus 0 is 3. Then 0 plus 3 is 3. So our answer would be 330,480. All right. So that's all I have today for multiplication. The next lesson will be division. I thank you everybody for your time watching this. Hope everyone has a good evening. Take care.